Hi there, I'm Borna, your organic chemistry tutor, and today I brought yet another solved mechanism problem. Let's get started on it. Alright, so this is the problem for today. You should be able to try this out if you have learned nucleophilic addition to aldehydes and ketones. So go ahead and pause the video and try this on your own. Alright, now that you're back, let's see how the solution goes. Let me start by saying that this looks a lot like a carbon of an enol, in other words, a carbon of an aldehyde or a ketone. And this too looks kind of like a cyanohydrin, except instead of an OH, I have an NH methyl. I'm not really sure. You know what? I'm just going to go ahead and number this. So I'm going to start here. 1, 2, 3, 4, 5. My suspicion is that this is going to remain 1, 3, 4, 5. If I'm wrong, we'll go ahead and address that. Now, it looks like the oxygen gets disconnected from, so breaking, I'm going to use red to show, and making, I'm going to use green. Now, it looks like the oxygen becomes disconnected from carbon 1. All right, and then carbon 1 gets connected to a CN, and it gets connected to an NH methyl. All right, now me thinking that carbon 1 is practically a masked aldehyde makes me think that the first step of this reaction is basically going to be the reaction of an aldehyde with a primary amine, which is going to give me an amine, but I'm kind of keeping an open mind. Let's see what is going on here. I have a very active double bond, so I'm going to think that this is going to pump electron density here. This is going to abstract an H+, converting it to this thing. All right, now this is very prone to nucleophilic attack, so probably methylamine would come in. And now that makes sense because remember, methylamine is getting connected to carbon 1, and this is probably how it gets connected. And notice that I'm taking two strategies. I'm numbering my carbons and I'm thinking about what makes sense. And I'm doing these both in tandem. All right, so if methylamine attacks that, I'm going to get something looking like this. And most likely my methylamine gets deprotonated to basically lose its positive charge. So let's do that. And then that gets us to a pretty stable neutral intermediate, and then we can gather our thoughts and see what is going on at that point. All right, now how about I protonate this oxygen and make it leave as a leaving group. Let's see what that does for us. That takes care of the disconnection of carbon 5 and that oxygen. I think this is a good move. So I'm making this positive, and you know what? I'm going to use the lone pair of this nitrogen to kick this out, and that takes care of that cleavage that I was worrying about, disconnection of carbon 5 and the oxygen. And this is going to look something like this. It's an iminium ion. And to this, now if I add NaCN, which is basically Na plus Cn minus, that is going to give me the product. Because the iminium is very, very electrophilic, so it readily gets attacked by Cn minus to give me the product. And notice that I'm forming a new stereocenter here. And that new stereocenter has to be racemic because the iminium can get attacked from either face. So there is an equal chance for forming the R enantiomer and the S enantiomer. Wasn't that difficult? Well, I hope you liked this video, and if you did, please don't forget to hit the like button. That's going to help my channel grow. Also, subscribe to this channel to see more solved problems, tips and tricks, and tutorials. I promise it's going to be worth it. See you in the next video.